All right. Good morning, Victor, Bernadette, Chriselle, Kiefer, and Jim Brethren. So today we'll continue our discussion about Laplace transforms, in preparation sa exam. Exam yun na sa Monday. So hopefully you're ready or getting there at least. Medyo mahaba-haba, no? Kasi saan nga ba tayo magsisimula? Mag-start tayo sa um, non-homogeneous general linear differential equations hanggang dun sa matatapos natin today, which is about inverse transforms. I was thinking kanina, feeling ko kaya kong tapusin hanggang 4.7 ngayong araw na to by integrating chapters 4.6 and 4.7 together. Kasi basically nasimulan ko na yung buo natin gagawin with this last two sections because section 4.6 will introduce us to how Laplace transforms can be used to solve or this will teach us the basic building block na kailangan para magamit yung Laplace transforms para makapag-solve ng ng differential equations, which is in 4.7. So basically the structure of the module I, discuss niyo muna yung inverse transform sa 4.6, tapos saka in-apply yung mga natutunan natin from sections 4.1 to 4.6 sa pagsasolve ng ordinary differential equation hanggang sa chapter 4.7. But I thought if I'll try to finish everything today, that means the coverage for Monday will also increase, ano? So gagawin ko na lang ngayon, tatapusin ko tong chapter 4.6 with some examples. So let's take our time and see how these examples are solved. Tapos Wednesday next week magkikita-kita pa rin tayo to discuss section 4.7, and probably I can introduce another section which is very helpful, how to use differential equations in solving or how to use Laplace transforms in solving systems of ODEs. Kasi yun yung parang kulang sa atin ngayon. Hindi tayo nakapag-discuss ng systems of ODEs, which is very important whenever dealing with some real-world problems, all right? And then siguro, so again, our exam is on Monday, December 12th, 10 to 12 noon sa Math Building Room 101. So magkita-kita tayo on Monday. Ito pala, magpapauna na ako. Manggagaling ako sa UP Rural High School. So I have a teaching demo there. One of my MST students will be doing his final demonstration. 8 to 9:30 yung schedule ng demo niya. Pero after 9:30, meron pa kaming deliberation kung okay ba yung demo or not. So siguro mga 20 to 30 minutes yon. Tapos from there, magbibiyahin pa ako mula sa rural papunta sa math building. So siguro if I'll be late, pakiantay ako, right? So siguro mga at the latest 10:15 or 10:30 tayo mag-start. Kung tatagal yung demo, but I plan to be there by 10. So you should be there at 10, but please wait for me. I'll be there, and then don't worry, I'll give you 2 full hours to finish the exam. Oh, by the way, just a quick update, we decided na iba-iba yung exam nung tatlong lectures. So ako yung maggagawa ng exam nyo. I don't know if it's a good news or a bad news for you. So yeah. Pero what I plan to do is this. I'll test you with the minimum learning competencies. Hindi siya katulad, don't worry, hindi siya katulad ng midterms na bago nyo masagutan yung isang problem, kailangan nyo siyang titigan ng isang oras. All right? You don't have the luxury of time. So most probably, I'll just ask you some minimal questions, right? I just want to see that you can solve things really, or that you are the one solving or doing the solutions on your impressive midterm exams, Kasi ang gaganda ng solutions niyo sa midterm exam. I just want to convince myself, kahit naniniwala naman ako sa inyo, I just want to see good proof na kaya niyo talaga mag-solve, So expect siguro 80% ng exam ay medyo mechanical, straightforward. Then probably siguro lalagyan ko siya ng mga 20% na para lang masayahan kayong mag-solve. Yung medyo pag-iisipan nyo ng konti. And then after all, we still have a part 2 of the exam, which will cover those that were not included in the pre-final exam, right? Another housekeeping matter, today is the deadline for you to answer the student evaluation of teachers. So go to SAIS and then evaluate me on there. Tapos, after nyo magsagot sa SAIS, balik kayo sa Canvas. Tapos, sagutan nyo yung quiz about asking you whether you have already answered the SCT, ano? So, etong usapan natin, walang extension yon. So, siguraduhin nyo after magsais, pupunta tayo kay Canvas. Kasi kapag ka nag-close yung Canvas submission, hindi ko na siya uli i-open. So, if you fail to answer the Canvas quiz, kahit nakapagsagot na kayo kay SAIS, sorry, 0 na kayo dun sa quiz na yon. And I think I put it as part of your final project, so you'll get a 0 for that. Part ba ng project or part ng homework yun? I forgot. Homework ba siya? Sorry, nalimutan ko kung homework or part ng project yung student evaluation. But still, it will be part of your grade. So dahil dun sa student evaluation, wala akong access kung sino yung mga nagsagot or hindi. So ang tanging panghawakan ko na nagsagot kayo ay yung sagot nyo dun sa quiz. So answer yes after you have submitted your size evaluation of me, right? Kasi yun lang talaga yung magiging basihan ko para malaman na nagsagot kayo. All right? I hope that's okay. Do that within the day because afterwards, you'll get a 0 kung hindi nyo pa siya nagagawa. Okay, on to the main topic for today, inverse Laplace transforms. So basically, in the last few days, we talked about Laplace transforms, how they are defined, and what are the Laplace transforms of the basic functions. Kasi sabi ko nga, ang idea natin, meron kang ODE in the t domain or in whatever variable. So in one domain, we will translate this into another problem in a different domain, namely the Laplace domain, by taking the Laplace transform of both sides of our equation. Kaya mahalaga na marunong kayong mag-take ng Laplace transform kasi yun yung magiging unang step dun sa ating alternative solution to the ODE. And then we learned last meeting na may magandang property kasi pagka involved ang differentiation sa Laplace transform. Because basically, the Laplace transform of a derivative turns into a algebraic equation. Nawawala yung mga derivatives. So kung meron kang degree n, meron kang order n na derivative, nagiging s to the power n times the Laplace transform of your function minus a linear combination or minus a polynomial in s weighted by the function values of the lower order derivatives. So in essence, pag nag-Laplace transform ka ng something na may derivative, ang lalabas ay wala ng derivative. So basically, in the Laplace domain, parang nawawala yung mga derivative. Right? So the derivatives in the time domain vanish at the Laplace domain. Kaya maganda kasi once we have the equation in the Laplace domain, it will be algebraic in the function f. So ang problema ngayon is solve natin yung algebraic equation na yon para makita ano yung itsura ni f tilde. Alright? Or ano yung itsura ng Laplace transform ng function na hinahanap natin. So we'll do a long process. I think I illustrated this last time. Where was that? I don't know where it is, but I'm sure I did it. So meron akong example. Can't find it. Can't find it. Pero meron akong example na nag-Laplace transform tayo ng isang equation, tapos sinolve natin saan equal yung x tilde. Saan equal yung Laplace transform ng solution. The only missing piece now in our puzzle is how to translate the solution that we got in the Laplace domain back to the time domain. Kasi nga, original problem nasa time domain, so kailangan mula sa S domain o sa Laplace domain, bumalik tayo sa time domain. And if we will be able to do that, we're going to find a function x that solves the given ordinary differential equation. All right? So yun, titingnan natin sa chapter 4.6, paano ba ina-undo yung ginawa ng Laplace transform? Or what is, or how do we find the inverse Laplace transform of a certain function in the S domain? All right? And we start off with definition 4.6.1. It tells us that if the Laplace transform of big F is little f, then we say that big F is an inverse Laplace transform of f of s. It's called an inverse Laplace transform because there could be various representations for the inverse Laplace transform. right? So we just need to find one. Humanap ka ng isang function na pag nilaplace transform natin ay si little f. Yung function na yon, yun yung tinatawag natin na inverse Laplace transform. So basically, we are just undoing what we did last time. So kung dun sa table nyo ng Laplace transforms na sinasaulo ngayon in preparation for the exam, and you need that because I will not give you any cheat sheet, ano? Baliktad naman yung titingnan nyo. Ang given naman sa inyo ngayon, yung may mga S. Ang goal, hanapin ano yung function t or function in the variable t. Okay? So some quick illustration. Note that we know, hopefully you already know that the Laplace transform of cosine 2t is s over s squared plus 4, right? Because the formula is s over s squared plus k squared. So that's our little f. Now, the inverse Laplace transform, denoted by L inverse. So the inverse Laplace transform of s over s squared plus 4 is equal to cosine 2t. Kasi pag nilaplace transform yung cosine 2t, ang sagot ay s over s squared plus 4. Okay? I hope that's clear. Medyo nakakalito nakakalito ito sa simula kasi nga nasanay tayo na function t ilalaplace transform. Ngayon baligtad, given sa atin yung function in S, kukunin natin yung inverse Laplace transform. Okay. Some more examples. So what's the Laplace transform of 3 over s squared plus 9? We need to think, what should be Laplace transform to get 3 over s squared plus 9? Spoiler kasi yung slides. So that means we need to look for the function na ganito yung itsura ng Laplace transform niya. Eh, isa lang naman yung may constant over s squared plus a constant. It's the Laplace transform of the sine function, right? It's k over s squared plus k squared. And luckily, when you take k equals 3, we get exactly this guy, right? And remember, this is the Laplace transform of sine kt. So that means the inverse Laplace transform of 3 over s squared plus 9 is sine 3t. There we go. Okay. And similarly, the other one, Laplace transform ng 1 over s minus 5. Think of saan nga ba tayo nakakakita ng 1 over s minus 5 na Laplace transform? Nakita natin yan sa formula na 1 over s minus k, which is the Laplace transform of e to the kt. So that means here we simply need to take k equals 5, then we get the inverse Laplace transform of 1 over s minus 5 to be e to the 5t. There we go. Okay? So it seems straightforward, pero believe me, nakakalito ito. So I hope by now, sanay na kayo mag-Laplace transform. So over the weekend, kailangan nyo lang i-train yung utak nyo to think backwards. Ano? So given si S, babalik tayo dun sa Laplace transform. Right? Of course, we just don't see this very basic problems. Ano? Parang lokohan kung ito lang yung ano. Kung ito lang yung itetest ko sa inyo, sabihin nyo, sir, sampal sa katalinuhan ko yung mga examples na yan. So wag po sanang ganyan sa exam. Ano? So let's look at more complicated functions little f. Tapos hahanapan natin siya ng inverse Laplace transform. But to aid us in that endeavor, kailangan natin ng ilang mga theoretical results. First important theorem is theorem number 1, which tells us that the inverse Laplace transform is also linear. If you want to get the inverse Laplace transform of a linear combination of two functions f and g, then the answer is just a linear combination of the inverse Laplace transforms, right? So inverse Laplace transform, pwede mong i-distribute over the sum. Tapos yung mga scalars, lumalabas sila ng inverse Laplace transform. Alright? So may linearity property pa rin yung inverse Laplace transform. And then theorem 4.6.2 is another important theorem because it will help us later whenever we need to shift the center of the expansion of the function f. So parang kapag yung argument ng function little f natin o nung Laplace transform little f natin ay hindi function ni S, pero it's a function of s minus a, then we can adjust. We can translate the inverse Laplace transform a units to the left by introducing a multiplier e to the negative at. Okay? So pag minultiply mo yung inverse Laplace transform ni f of s minus a by e to the negative at, makukuha mo lang ay yung inverse Laplace transform ni f of s. So I'll show you later how useful theorem 4.6.2 is. Okay? So pakitandaan itong dalawa, if you need to screenshot it and put it in front of you while we're answering some problems, kindly do so kasi gamit na gamit natin itong mga theorem na to in our discussions. Okay? So there are, I think, 6 examples here in the slides. But since hindi naman ako nagmamadali, I want to answer them step by step. So alis ako dun sa slides. Gagawa ako ng panibagong note para mano-mano nating isolve yung mga problems na ito. Alright? So I hope that's okay. Kasi hindi ko na tinanggal yung wala akong kopya nung PPT X na file. So hindi ko mabura yung mga solutions. So let me just create another note. And let's answer some examples. But before that, do you have any questions about those, the introduction, the definition of the inverse Laplace transforms, and some governing theorems? Wala naman? Sounds straightforward, no? Kailangan lang tandaan nyo talaga yung mga formula, and you should be adept in working backwards. So as first example, let's try this. So the goal here is to find the inverse Laplace transform of the following equations. So let's do, say, number 1. Let's take the inverse Laplace transform of 15 over s squared plus 4s plus 13. Okay, so kapag quadratic yung nasa denominator, so we will be thinking maybe, just maybe, I can write it in the form, or the denominator may be written in the form s squared plus k squared. Yun yung goal natin. Kapag quadratic yung denominator, baka pwedeng masulat ko siya something involving s squared plus another constant. So that means whenever you see a quadratic polynomial in the denominator, try to complete the square. All right, so sana tandaan nyo pa kung paano mag-completing the square. But basically, for completing the square, kailangan mo lang isulat yung, or kailangan mo lang mag-isolate ng isang perfect square trinomial plus some leftover constant, and then you'll get the completed square, or yung form na nasa completing the square. So in this particular case, we have s squared plus 4s. So what's the completing term here? Do you remember how to compute the completing term? So para siya ay maging perfect square trinomial. So remember, if you already forgot, ang ginagawa natin, tingnan mo to. So meron akong s squared plus 4s. Yung middle term ay 4. Take ko yung half niyan. So 4 divided by 2 ay 2. Tapos si square ko, meaning the completing term here is 4. Why is it the completing term? Because I can now factor this trinomial as s plus 2 quantity squared from the special product, right? Remember, the special product for a plus b squared is a squared plus 2ab plus b squared. Right? So we simply need to divide this by 2, or the numerical coefficient by 2, and then square it to get our b squared. Okay? So pag ginawa ko yon, so para pala magkaroon ng perfect square trinomial, kailangan meron akong s squared plus 4s plus 4. Kaya lang, I want to maintain equality with the given problem. The given problem has a total of 13 constants added to it, right? Kaya lang itong completed square form natin, 4 pa lang yung constant, so kulang pa siya ng siyam. So kailangan ko ibalik yung 9 dito, alright? But I'll keep in mind that I am considering the first 3 terms to be a single entity or a single group, so that I can write it in factored form as 15 over s plus 2 quantity squared plus 9. Okay? Now, this is almost, just almost, in the form of the Laplace transform of the sine function times a constant 15, right? Remember, sa cosine, meron kang 1 over s squared plus k squared. That's the Laplace transform of the cos of the sine function. That pala may times k pa rito, right? So k over s squared plus k squared, ito yung target form natin. However, yung problema natin dito ay meron kang s plus 2. Eh, ang gusto ko s squared lang yung nasa denominator. The constant is easy to manipulate because I can just put it out or introduce some constant factors and then divide everything up later to preserve equality with the given problem. So wala mo na akong problema sa taas. Ang pinakamalaking concern ko ngayon, s plus 2 ito. But remember, meron tayong theorem, theorem number 2, which allows us shifting by some units to the left. In this particular case, I want to shift s plus 2 by 2 units to the left. Okay? So remember, gusto ko mag-shift 2 units to the left. So ibig sabihin, kailangan ko mag-multiply ng e to the negative 2t dun sa Laplace transform. Let me double check that. Yes. Kailangan ko mag-multiply ng e to the negative at para ma-move yung para ma-move yung s by a units to the left. So pag gusto ko mag-minus a dun sa loob ni little f, kailangan mag-multiply ako ng e to the minus a times t. Right? So in our problem here, I want to move s plus 2 2 units to the left. So I want to subtract 2 mula dun sa s plus 2. So magma-minus ako dyan ng 2. So dahil gusto ko mag-minus ng 2 dun sa lahat ng s plus 2s na nandun sa loob ng inverse Laplace operator, kailangan mag-multiply ako ng ng e to the negative 2t. Right? So by theorem 4.6.2, we'll be left with the inverse Laplace transform of 15 over s squared plus 9. Okay? And then here, this form now tells us that, oh, k should be equal to 3. Because this guy, by hook or by crook, should be k squared. Okay? So, do you follow, guys? Umpisa lang to medyo komplikado, pero later magiging mechanical ito, ano? So, k equals 3. Problem, I have a 15, but I remember theorem 1. The inverse Laplace transform is also linear. So scalars can freely go, scalar factors can freely go in and out of the inverse Laplace transform. I need the 3 to be left inside the inverse Laplace transform so that I can write it as sine kt, right? So dapat ito ay 3. So yung 15, gagawin kong 5 times 3. Yung 5 ilalabas ko kasi linear lang naman ang inverse Laplace transform. So I'll be left with 3 in the numerator of the inverse Laplace transform. So what I'll do is exactly that. Labas ko yung 5, copying ko yung e to the negative 2t, inverse Laplace transform ng 3 over s squared plus 9. And how do you get to 3 over s squared plus 9 in the Laplace domain? Following your table of Laplace transforms, we need to Laplace transform sine 3t to get this guy, all right? So that means the inverse Laplace transform or an inverse Laplace transform of 3 over s squared plus 9 is sine 3t. And we're done. That's the inverse Laplace transform. Okay. You can check, Laplace transform ito, makukuha mo ito. And I guess I included this as one of the appendices to the slides, ano? Dun sa table na sinulat ko last time na shinare ko sa inyo, meron ako dong Laplace transform ng, if you remember, e to the negative alpha t sine beta t. Sabi ko, ang Laplace transform nito ay equal kay beta over s plus alpha squared plus beta squared, provided that s is greater than negative alpha. So, ibig sabihin, pwede nyo palang, kung sa ulado nyo yung buong table na shinare ko sa inyo, pwede palang pagkakita nyo nito, sabi nyo, beta is Actually, hindi pala kagad, no? Kailangan nyo munang i-factor out talaga to as 5 and 3 para yung beta, alam nyo, ay equal kay 3 kasi dapat ito ay beta squared. Tapos yung alpha ay 2. So magkakaroon ka ng negative 2t times sine 3t. Tapos yung leftover na 5 sa labas. So you can do this approach, or if you're good at memorization, makikita mo, ito yung product, ito yung Laplace transform o a scalar multiple ng Laplace transform ng exponentially decaying sine wave. Right? But either way, you'll get there. You should just be patient enough. Ano? Let me just erase this. Great. That's it. One question down. Do you have any clarifications to this one? Isa pa? Okay, let's try one more. Number 2. Inverse Laplace transform ng 1 over s squared plus 2s plus 5. Okay. Actually, katulad lang ito nung example number 1. So again, meron akong quadratic polynomials sa denominator. So I'll try to complete the square first para maiporma ko ito ng Laplace transform ng isang sign. Right? Kasi wala akong s sa taas, so no choice ako, dapat constant yung numerator. Right? So I'll do that. Inverse Laplace transform ng 1 over s squared plus 2s. I'll get half of the middle term. Half of it is 1. Square that. That's going to be our completing term. So I should have a plus 1 here. That's my first group. But to maintain equality with the original denominator, I need to supply the missing 4. Para pag sinimplify ko ito, papalik lang ako rito. Right? Then I'll do the factorization. This would be the inverse Laplace transform of 1 over s plus 1, quantity squared, plus 4. Okay. And then I'll do the translation. I need to translate s plus 1, 1 unit to the left, para maging s squared na lamang siya. But again, translation to the left requires a multiplication by e to the negative. How many steps do you want to take? To the left times the variable t. So ibig sabihin nito, magkaka-multiplier ito na e to the negative t para yung s, lahat ng may s, mapapalitan ko ng s minus 1. So instead of an s plus 1, I will have an s minus 1 plus 1. Kasi yung multiplication ng e to the negative t, ang epekto niya lahat ng s. Again, I want to emphasize that. Hindi lang yun nandito. Lahat ng s na makikita nyo dun sa loob ng inverse Laplace transform, mapapalitan ng s minus 1. Luckily, in the last 2 examples, meron lang tayong s plus 1, isa lang yung s na involved, so isa lamang yung mamaminusan ng 1. So itong s na to magiging s minus 1, kaya lang may plus 1, so magiging mas simple siya, magiging s squared na lamang siya. Right? 1 over s squared plus 4. Okay? All right, and then, ano na yung susunod? Identify what the value of k is, right? So it screams inverse Laplace transform yan ng sign. Pero ano si k? K is equal to 2. Kaya lang wala akong 2 rito. So kailangan ko mag-introduce ng missing factor na 2. Pero parang dito ginawa sa slide. Tama pa ba ginagawa ko, guys? Double check nyo nga. Parang iba yung nakopya kong sagot sa slides. Tama pa naman so far? Tama naman, no? Okay, guys, sumuko kayo. Alright? So, k equals 2. So, ibig sabihin, kailangan ako magka-2 rito. Pero wala tayong malaking problema kapag constants lang yung kulang kasi linear naman yung inverse Laplace transform. So, pwede ko siyang isulat na, okay, ibigay natin yung gusto. Magka-2 tayo sa numerator, s squared plus 4. Pero para ma-maintain yung equality with the given one, I need to take the 2 that I multiplied back, all right? And that can be done by multiplying everything by 1/2 sa labas. Okay? So magka-cancel lang naman yan at yan, babalik ako dun sa original. So what we have now is 1/2 e to the negative t times inverse Laplace transform ng 2 over s squared plus 4, which is exactly of the form k over s squared plus k squared. So this is sine of 2t. End of story. Right? Double check ko nga dun sa slides. Ang nakopya ko lang ay e to the negative t sine 2t. Hold on. Yeah. Paki-correct yung slides. So, mali nga siya. Kasi ito, hindi to pwedeng maging Laplace, maging e to the sine, maging etong inverse Laplace transform. Hindi lang siya pwedeng maging sine 2t. Right? Do you agree? So, dapat ito ay may multiplier na 1/2. Okay? It's a good thing. We're solving everything by hand. Double check natin yung nasa slides. Okay. Now, let's try another one. Inverse Laplace transform ng s over s squared minus 4s plus 13. Now, this is still similar to the first two example, except that there's an s in the numerator. Tapos quadratic pa rin yung nasa ilalim. So, quadratic yung nasa ilalim, so malamang pwede ako mag-completing the square. Pero pag nag-completing the square ko, may s pa rin sa numerator, will that cause us a problem? No, it won't, because ang Laplace transform ng cosine ay talagang may s sa ibabaw. So we're still good. Okay, so we're still good. So let's just do the same things that we did earlier, right? This time with the function s squared minus 4s plus 13. So completing the square ulit, inverse Laplace transform ng s over s squared minus 4s, take half of the middle term, that's 2 quantity squared. So we should get a plus, we should have a plus 4 para kompleto yung square, right? Yung group ko yan. Pero dahil plus 13 ito originally, meron pang kulang na plus 9. Okay, to maintain equality. And then write it in factored form. We're gonna have inverse Laplace transform the s over s minus 2 quantity squared plus 9. Okay. Now, it's just a little different from what we encountered last time kasi kanina s plus something quantity squared yung nakukuha natin. Kaya lang to s minus. So, ibig sabihin dapat i-translate ko yung s minus 2 units papunta sa kanan para maging s na lamang siya. So, my goal here is to have s replaced by s plus 2 para pag ginawa ko yung minus 2, magiging s na lamang. Pero remember, pag meron kang s minus a dun sa loob ng Laplace transform, you need to multiply it by e to the negative at so that ito ay maging s na lamang. Hindi, baliktad. So meron kang yung s minus a, you get an s minus a if you multiply your inverse Laplace transform by e to the negative at. But now I want to have an s plus 2. So that means I need to multiply this inverse Laplace transform by e to the negative negative 2. So that means a net of e to the 2t. Right? Kasi gusto kong mag-plus ng 2 kay s. S plus 2 minus 2. So ibig sabihin may plus 2 ako na i-introduce. Yung plus 2 na i-introduce ko dapat exponent siya ni e times t. Right? That means this is e to the 2t times s times the inverse Laplace transform of s over s squared plus 9. Pero yung caveat ko nga kanina, hindi nga lang pala yung s sa denominator ang shift 2 units this time to the right because our multiplier is e to the 2t. So, ibig sabihin, dapat yung nasa numerator mapapalitan din ng s plus 2. Right? Kasi ang idea, pag nag-multiply ka ng e to the 2t sa isang inverse Laplace transform, lahat ng s mapapalitan ng s plus 2. So this guy gets replaced by s plus 2 minus 2. That's how we got the s squared in the denominator, but there's an s in the numerator. That s will also be replaced by s plus 2. Okay? All good? At mukhang mali na naman yung nandun sa slides. Alright? Inopya ko kasi dito sa code ko yung sagot sa slides. Pero parang mali siya. Alright? So, sir, magkakaproblema ba ako dito? Kasi yung sa cosine, wala naman siyang plus eh. S lang siya dapat. Ano kaya yung pwede kong gawin? Sana pala nakikita ko sa Teams kung may nagta-type, no? Para pwede ako magantay. Ayaw nyo pa kasi mag-unmute pag sasagot eh. Gusto nyo pa nagta-type sa chat. Anyway. So what I can do is, again, appeal to the linearity of the inverse Laplace transform. Hahatiin ko to into, or I'll decompose it into a sum. Tapos ang Laplace transform ng sum ay sum lang naman ng Laplace transform. So I can do term by term inverse Laplace transformation. Okay? So that's the plan. So I'll write it as yung e to the 2t times inverse Laplace transform. Sige, step by step ko muna siyang gawin for starters. Ano? Ng s over s squared plus 9 plus 2 over s squared plus 9. Okay? I just split the sum inside the inverse Laplace transform into 2, and then I'll appeal to the linearity of the inverse Laplace transform. So magkakaroon lang ako ng inverse Laplace transform ng s over s squared plus 9 plus inverse Laplace transform ng 2 over s squared plus 9. Again, we can only do this because we knew that the inverse Laplace transform is a linear operator. Theorem 4.6.1. Without that, hindi natin kaya itong i-split. Pero luckily, meron tayong theorem na yun. Okay? Tapos ngayon, pwede ko nang i-Laplace transform bawat isa sa mga ito. So we'll have e to the 2t, inverse Laplace transform ng s over s squared plus 9. Alam ko ito ay cosine. Cosine ng kt. Ang k ay yung square root ng addend sa denominator. So it's cosine 3t. Plus Laplace transform ng 2 over s squared plus 9. Now, there's a little bit of a problem here. Because ito dapat ay cosine. Sa cosine, dapat k, sa sine pala to. Dapat k over s squared plus k squared. I can't do anything with the denominator. I need to force the issue that 9 is k squared. So ibig sabihin, k is equal to 3. That means by hook or by crook, we should have a 3 in the numerator. But how do we get the 3 in the numerator? Just put 3 there. Pero dapat ma-multiply siya by a scalar so that 2 yung magiging final answer para equal pa rin siya sa taas. So that means we need to multiply we should write 2 as 3 times 2/3. Tama ba? Para pag nag-simplify ka, 2 pa rin yung makukuha mo. Pero ngayon, meron ka ng 3, tas yung 2/3, pwede mong ilabas ng Laplace transform. Alright? So we'll have 2/3, parenthesis pa, naka-brackets pa pala yan. So 2/3, tas ito ay magiging 3 na, no? 3 over s squared plus 9 has inverse Laplace transform equal to sine of 3t. End of solution. Okay. Let me just see what the slides did. Okay, so kindly correct this one. Ano yung mali dito sa ginawa ni slides? Ano siya? Parang spot the error. Bakit mali yung nasa slides? Para hindi niyo na siya gagawin. Sabi ni Kiefer, dumiretso agad sa cosine. Well, yes, pero bakit siya na-tempt na dumiretso sa cosine? Yeah, Curcel is right. Yung s sa numerator na original, hindi niya pinalitan ng s plus 2 kasi nag-shift ka ng nag-introduce ka ng e to the 2t. So dapat lahat ng s's dun sa loob ng inverse Laplace transform mag-shift ng 2 units to the right. So that means all s's should be replaced by s plus 2. Ginawa niya lang yung sa denominator, kinalimutan niya yung nasa numerator. Lugi yung numerator. All right? So that's a problem with this solution. Okay. All right. So let's see some more. Sanayan kasi yan. And this is really a testament to math being not a spectator's game. So we really need to get our hands dirty, para masanay tayong paggamit ng mga inverse Laplace transforms. Though sa undergrad, mas gamit to ng mga engineering students kaysa sa ating mga math. Kaya parang sabi nga namin dati, mas magagaling ang mga engineering students na mag-Laplace at inverse Laplace transform kasi araw-araw nila tong ginagamit. So tayo, parang sa 151 nyo lang to gagamitin unless in your thesis or your SP, you will work with differential equations wherein Laplace transforms are very much handy. Okay? So again, let's try some more. Number 4, inverse Laplace transform ng 2s plus 3 over s plus 4 quantity cubed. Okay. Ito na yung medyo hindi pa pala ito malaking issue. Kasi hindi na siya papasok dun sa form ng sines and cosines. Because here, when you expand the denominator, you'll have an s cubed, hindi siya quadratic, so hindi nagagana yung techniques natin kanina. Pero meron kang s plus 4 quantity cubed. Saan natin to pwedeng i-compare? At least yung denominator muna. Kasi yung numerator, pwede natin siyang i-manipulate later. Ano yung problema sa denominator? Komplikado yung denominator kasi meron tayong s plus 4 quantity cubed. What if I shift it first? All right? Gumamit ako ng exponential shift. Lahat ng s's palitan ko ng s minus 4. I shift all s's to the left by 4 units. So the denominator will be s cubed. Do we have an inverse Laplace transform that involves s cubed or a power of s? Yes, inverse Laplace transform ng ng t to the n, right? So siguro rito I want to recall that the Laplace transform of t to the n ay equal kay n factorial over s to the n plus 1. So pag may power ka ni s sa denominator, tapos may constant ka, which is a factorial, then you should be good. But again, our lesson kanina, pag may kulang ka na constant factor, madali lang siyang i-introduce. Kasi i-divide mo lang siya uli, mabalik ka dun sa n factorial na gusto natin. Right? So, yun yung plan. Siguro, i-exponential shift ko muna ito. So I want to move s 3 units to the left. So in order to do that, I'll need to multiply the inverse Laplace transform by e to the negative 4t, right? So that means lahat ng s's mapapalitan ng s minus 4. So let's do that first in the numerator para hindi tayo matulad dun sa slides na nakalimutan niyang gawin to kanina. So move tayo 4 units to the left plus 3 all over. This would be s cubed. Oops, nawala yung inverse Laplace. Okay? Tapos simplify ko muna yung expression sa loob ng inverse Laplace. So magkakaroon ako ng 2s minus 8 plus 3, so minus 5 over s cubed. Good. And then I'll split this up into 2 pieces because I don't know how to handle a binomial in the numerator. Wala yan sa listahan natin kanina. So I'll split it up into two terms. So I'll have a 2s over s cubed minus 5 over s cubed. And then I can further simplify the minuend inside the inverse Laplace transform as 2 over s squared minus 5 over s cubed. Okay? Kasi ito na yung i-inverse Laplace ko. So remember, the rule is t to the n, ang kanyang Laplace transform ay n factorial over s to the n plus 1. So the exponent in the denominator is n plus 1. So dun sa unang term, n plus 1 is equal to 2. So that means n is equal to 1. So kailangan meron tayong 1 factorial sa taas. Pero meron akong 2. Ano bang 1 factorial? 1 lang naman. So I can simply take 2 out of the Laplace transform. Magkakaroon na lang ng 1 over s squared. So Laplace transform ng 1 over s squared ay t to the first power. Agree? So this is e to the negative 4t times 2 times t. Right? Dito sa pangalawang term, remember, ang target ko uli ay ang Laplace transform ng t to the n ay n factorial over s to the n plus 1. Dun sa pangalawang term, ang n plus 1 ay 3. So that means n is equal to 2. So we need the 2 factorial in the numerator. But 2 factorial is 2. I have a 5. So I can write 5 as 5 times 2 fifths. Sorry, baliktad. This should be 5, what? Baliktad. Gusto ko magkaroon ako ng 2, which is 2 factorial times 5 halves. Right? Gusto ko kasi matira yung 2 dito, ilalabas ko yung 5 halves. So magkakaroon minus 5 halves. Tapos ito ay magiging Laplace transform or inverse Laplace transform ng 2 over s cubed. And this time, this is 2 factorial. This is s to the 2 plus 1. Ang inverse Laplace transform niya ay t squared lamang. Okay? So sa simula talaga kailangan yung sanayan. Actually ngayon nalilito pa rin ako dun sa n factorial over t to the n plus s to the n plus 1. So kaya kailangan ko siyang isulat side by side on my scratch paper, ano? So wag mahiya na mag-scratch paper, ano? Kaysa kaya kong magpapanggap kayo na kaya niyong i-mental tapos in the end mali naman pala, no? Okay? Good? All good? Yeah, we still have 2 more examples and probably an additional one later. So let's jump to problem number 5. Of course, medyo limited lang yung mga pwede nating kunin ng inverse Laplace transforms kasi kokonti lang yung nandun sa table na binigay ko. But if you look at literature, mahaba yung listahan ng mga inverse ng Laplace transforms and hence ng inverse Laplace transforms. Pero don't worry, sa exam doon lang ako mag-stick dun sa extended list or extended table na binigay ko sa inyo. So just remember those formulas. Okay, number 5, inverse Laplace transform ni s squared minus 6 over s cubed plus 4s squared plus 3s. S cubed plus 4s plus 3s. Okay. Now, this is a big problem because the numerator is now more complicated. It's a quadratic function. The denominator is also complicated. It's a cubic function. All right. So parang hindi siya sine or cosine, hindi siya basta-basta papasok dun sa mga nasa table natin. So you have to analyze the function inside the inverse Laplace transform. And one way to do that ay yung isa sa mga paborito nyo, partial fraction decomposition. All right. So I'll just do the partial fraction decomposition first, independent of the Laplace transformation. Copyin ko lang to. Gawin ko muna siyang, okay, pwede ako mag-factor dito. Right? Factor ko yung denominator. I can factor out an s, and then I'll have an s squared plus 4s plus 3. Pero yung s squared plus 4s plus 3 ay pwede kong i-factor as s plus 3 times s plus 1. S plus 3 times s plus 1. Right? And then magpa-partial fraction decomposition ako para magkaroon ako ng magkaroon ako ng A over yeah. So that I'll have an A over S plus B over S plus 3 plus C over S plus 1. Okay? Tapos we need to solve for the constants A, B, and C. All right? So in this case, ano yung mangyayari? So I'll have an S squared minus 6. Gagawin ko ito at saka ito. I-multiply ko sila both sides by the denominator para lang mawala yung denominator. So I'll have, this would be A times S plus 3 times S plus 1. Then I'll have B times S plus 1. And then plus C times S plus 3. So this is all your good old familiar partial fraction decomposition. Yeah. And now I want to find what's the value of A, B, and C. You can give arbitrary values for S, but choose the S's that will annihilate some of the terms or some of the factors. Some of the terms in your expansion. So halimbawa, I can choose S to be equal to 0 because this equation should be true for any S. Dahil totoo siya, dapat sa lahat ng S's, pwede akong mamili ano yung mga pinaka-convenient na S na gamitin para sa atin. Usually sila yung mga magpapa-zero dun sa mga factors para madali yung system na makukuha natin, right? Actually, para hindi na nga tayo mag-system, If S is equal to 0, this guy will be -6. And then this guy will be what? 0. So 3 times 1, so I'll have a 3A. This guy will be 0. This guy will be 0 because S is equal to 0. That means A is equal to -2. Okay. And then if S is -3, I'll have, this is -3. So we'll have 9 minus 6. So we'll have 3 equals, this will go to 0. This will go to 0. Ito lang yung matira. S is -3. So I'll have B times -3. Times -3 plus 1, -2. So we'll have 6B. So that means B is equal to 1/2. And then if S is, what's the last annihilator? The last annihilator is -1. If S is -1, we'll have -5 equals -1. This will be 0. This will be 0. S is -1. Tama ba? 2, -1. So I'll have -2C. So that means C is equal to 5/2. Right? So therefore, yung pagkakasplit ng Laplace transform natin, the original problem, or the original expression, ay pwede nating masulat as what? The inverse Laplace transform of 2 over S, right? So manggagaling siya dito. Ipa-plug in ko lang yung values ni A, B, and C na nakuha natin. Plus 1/2 times 1 over S plus 3 plus 5/2 may negative pala dito. Tama ba? -2 over S siya. 5/2 times 1 over S plus 1. Okay. So yan yung kukunin natin ng Laplace transform. And then you can do term by term Laplace transformation. Laplace transform ng -2 over S. Pwede mong ilabas yung -2. Inverse Laplace transform ng 1 over S. So pwede mo siyang tingnan as 1 over S minus 0. Yun yung Laplace transform ng e to the kt. Right? So this would be -2 e to the 0t. So that's just -2 and then plus 1/2. This can be thought of 1 over s minus k. Ang rule na ginagamit ko, if you remember, ang Laplace transform ng e to the kt ay equals sa 1 over s minus k. So ang k ko rito ay -3. So that means it's e to the -3t. And then similarly, I'll have plus 5/2 e to the -t. Okay. Or you could have done exponential shift here. That's fine. So magiging e to the -3t Laplace transform ng 1 over s. Pero ang Laplace transform ng 1 over s ay constant one. So you'll get the same thing. So that's the inverse Laplace transform. Any questions? Double check ko. Mukhang tama naman yung nasa slide, right? Ano sa tingin niyo? Kayang-kaya na may ganito sa exam on Monday? Or ayaw niyo nang umasa? Sir, lagi namang ganun eh. Sabihin mo madali lang, tas mahirap pala. Okay? All right, so let's see. The last example in the slides is this one. Inverse Laplace transform ng s over s squared plus 4 times s squared plus 1 plus 1 over s squared plus 1. Okay. Well, okay, all right. So I guess here we don't have any problem with this guy because ang inverse Laplace transform lang naman ng 1 over s squared plus 1 ay sine ng t, right? Kasi ito ay k over s squared plus k squared where k is equal to 1. So the last term is just sine t. The big problem is here in the first term. But we note, actually, thankfully, linear yung inverse Laplace transform. So pwedeng hiwalay ko talaga silang kinokomputan ng Laplace transform, right? So ito na lang yung problema natin for now. So siya yung ipa-partial fraction decomposition ko ngayon. Luckily, completely factored na yung denominator. So we don't need to do any further preconditioning or pre-processing of the denominator. So sulat ko na siya kagad na dalawang fractions na ang denominator ay s squared plus 4, tapos yung isa ay s squared plus 1. Because remember, ang rules sa partial fraction decomposition, pagka non-repeated yung denominators, laging ang numerator nila ay 1 degree smaller than the denominator. The denominator here is s squared plus 4. Non-repeated yung factor na s squared plus 4, so yung numerator nito ay as plus b. So dapat linear kasi quadratic yung denominator, dapat linear yung numerator. Tapos ganun din dun sa pangalawa, we'll have cs plus d. Okay. So you really need to look back at how partial fraction decomposition works. Marami pang cases. So tingnan nyo, kahit pahapyawan yung alalahanin. Paano kapag may square dyan? Mababago yung itsura noong right-hand side. So kindly review that. And then also, before you do the partial fraction decomposition, make sure first that the numerator has degree strictly less than the denominator. Okay. Dapat mas maliit lagi yung degree ni numerator kesa kay denominator. Kasi kung equal yung degrees nila, o mas malaki pa yung degree ng numerator kesa sa denominator, you do long division first. Right? Bawal mag-partial fractions ng greater than or equal to yung degree ni numerator compared sa denominator. Okay? So sana tandaan yung mga bagay na yun. Now, I'll multiply both sides by s squared plus 4 times s squared plus 1 to get rid of the denominators. So we'll have s equals as plus b times s squared plus 1 plus cs plus d times s squared plus 4. Okay. Now we have 4 unknowns here. Unfortunately, meron wala tayong annihilator na real numbers, right? Kasi kahit anong piliin nating value ni S na real number, never to magsi-zero, never to magsi-zero. So medyo problematic. Pwedeng I yung gamitin nyo para I squared, so negative 1 magsi-zero to. Kaya lang magkakaroon ka dyan ng AI, equals siya kay I din to, magiging negative 1 plus 3, ito ay magiging 3. Medyo magko-complex numbers kayo. If you know how to do complex arithmetic, then that's fine. Alright, kasi mag-work naman yon sa kahit na anong complex number S. Actually, ito yung hindi namin masyadong binabanggit, pero yung Laplace domain, right? Ang kanya talagang domain, ang domain ng mga functions sa Laplace domain ay subset ng complex numbers. So really, S is a complex number. Pero hindi natin to masyadong kino-consider pa sa ngayon. Alright? Or sa Math 151. Tinitingnan lang natin, or imagine natin si S ay isang real number. But in reality, S could be a complex number in the Laplace domain. Okay, so here I can give some other values for S and then try to solve a system of equations. Let's start with, kakayanin ko ba to? Dalawa yung unknown, or apat yung unknown. But anyway, hold on. Okay, let me see if I can do it this way. If S is 0, kasi ang haba pa rin ito. Kasi apat yung unknowns natin, no? A, B, C, and D. So dapat magkaroon ako ng apat na equations. So magkakaroon ako ng 4x4 system. So I need to give 4 S values. I'll start with S equals 0. So we'll have 0 equals, so ito ay mag-0, tapos ito ay mag-0, so 1. So magkakaroon lang ako ng B plus, ito ay mag-0, tapos ito ay mag-0. So I'll have plus 4D. That's our first equation. And then if S is equal to 1, then we'll have 1 equals A plus B times 2. So essentially that means, may plus pa pala to. Plus S is equal to 1, so I'll have C plus D times 5. And then if S is equal to negative 1, you'll have negative 1 equals negative A plus B times 2 plus negative C plus D times 5 then. And then give S equals what? S equals, halimbawa, you can give any number that you like. Say S equals 2. So look at 2 equals 2A plus B times 5 plus 2C plus D. And then I'll have times 8. So magkakaroon ka ng 4x4 system. Okay? So you can solve this 4x4 system any way that you want. All right? Pero hindi ko na ipapakita yung solution. This is an algebraic exercise. So eventually, tingnan ko yung nasa kodigo ko. Si A dapat ay, I think A should be negative 1/3. I think sa slides pinakita ito, yung solution niya. It might have used a different approach, but you'll get the same answer. Si B dapat ay 0. Si C ay equal kay S squared plus 1. So C dapat ay 1/3. Tapos si D ay equal kay 0 din. Let's just double check. Okay, totoo itong first equation. Then this guy, so pag pinlagin ko negative, so magkakaroon ako ng negative 2/3. Tapos ito naman ay magiging positive 5/3. Pag inad ko 3/3, I'll get 1. This value seems right. So pwede nyo i-double check. So algebra lang, paano masasolve to? So therefore, this is what we get. The original problem can be written as the inverse Laplace transform ng negative 1/3 times 1 over s squared plus 4 plus 1/3 times s over s squared plus 1. Sorry, nawala yung s dito. Plus 1 over s squared plus 1. Ito yung i-inverse Laplace transform natin. And then, since the inverse Laplace transform is linear, we can do term by term inversion, right? So I'm going to have negative 1/3. Inverse Laplace transform nito ay cosine ng 2t plus 1/3. Inverse Laplace transform nito ay cosine ng t. Okay. Tapos inverse Laplace transform nito ay sine t. And there you go. Okay. Any questions? Usually partial fraction decomposition yung kalaban nyo dito, no? At least dun sa mga elementary forms na binigay ko sa inyo. Okay? So try to absorb this for the next 30 seconds. Babalikan ko lang, hanapin ko kung saan yung dinagdag ko na example last time, where I gave you a preview of how the inverse Laplace transform can be used in solving Laplace transform problems. Hanapin siya. Ito. Okay. So recall we had this, or come on. So recall we look at this last time, right? So halimbawa meron kang initial value problem. You have an ODE. You are given the initial conditions x of 0 and x prime of 0. Kapag ka meron kang initial value problems, lalo na kapag ka 0 yung nandun sa yung initial value ni t, madaling gamitan ng Laplace transform. Directly mo siyang magagamit. Kung ito ay hindi 0, mag-change of variables ka para ito ay maging 0. Kasi kailangan ko yan para magamit ko yung theorem ng Laplace transform ng derivatives. Right? Remember what we did last time? Kinuha ko muna yung Laplace transform ng parehong side ng equation. So I got this. And then madaling i-compute yung inverse Laplace transform ni cosine t. I got this. And then on the left side, I applied the linearity of the Laplace transform. Tapos ano nga ba ang Laplace transform ng x double prime? Remember, ang Laplace transform ng x double prime ay s squared kasi second order. So mata-translate lang to sa multiplication by s squared. Kung triple prime yan, ito maging s cubed and so on, right? Degree n, order n derivative will translate to a multiplication by a degree n na s, right? Times the Laplace transform of the unknown function x, tinawag ko siyang x tilde, pero yung theorem natin sa differentiation ng Laplace transform, minus decreasing powers ni s, tapos pataas na derivative, right? So s, tapos yung function value at 0, minus x, minus s to the 0, times function value ng x prime. Plus Laplace transform ng x, tinawag nating x tilde. Equal dun sa right-hand side. Tapos sabi natin, eto na. Apply ko yung initial values. Ang x of 0 ay 0, so this second term vanished to 0. X prime of 0 is equal to 1. Hence, we'll get s squared plus x tilde s minus 1 plus x tilde s equals this guy. Tapos, in-add ko na lang yung 1 dun sa kabila. We got this. Alright? Tapos nakita natin, pwede ako mag-divide both sides by s squared plus 1 and we will get this. Ito yung nabiting kong example last time. Sabi ko sa inyo last time, ito na yung solution sa Laplace domain. So all we need to do is to translate this into the, translate it back to the time domain. Tama? K ba yung ginamit ko? K pa pala yung ginamit ko, pero alam ko na rito ang K ay equal K1. So, S squared plus 1 na yan. S is greater than 0 pa rin, right? So, this is 1, this is 1. So, this is 1. Tama ba? Right? So, dapat nga, yeah. Ah, sobra. What happened? Hold on. Okay. Kaya pala kakaiba. Kasi nga sa example ko, dun sa notes ko, cosine 2t yung binigay ko. Dito, cosine t lang yung nabigay ko, kaya ganun yung itsura niya. But anyway, that's still fine. So what we'll have here is that x tilde of s is equal to s squared over s squared plus 1 squared plus 1 over s squared plus 1. Inisip ko, kaya ba natin itong i-Laplace transform, i-inverse Laplace transform? Well, yeah, let's try. So pag kinuha ko yung inverse Laplace transform ng both sides, okay, maging inverse Laplace transform ng s squared over s squared plus 1 quantity squared plus 1 over s squared plus 1, right? The inverse Laplace transform of x tilde is simply x of t, right? Kasi ito yung ginawa natin kanina. Nilet natin ang Laplace transform ni x ay si x tilde. So, ibig sabihin, ang inverse Laplace transform ni x tilde ay si x. So, ang kailangan ko na lang ngayong mahanap ay ano ang inverse Laplace transform na nandito sa kaliwa. Alright? Ang magiging problema ko na lang ay yung inverse Laplace transform ng first term. Kasi alam ko na yung inverse Laplace transform ng second term ay sin t lamang. Oh, hold on, guys. Let's see. Mm-hmm. Bakit naging S squared to? Ngayon ko lang din-double check. Yun yung sinabihan last time. Sinisip pa kayo no? Dapat wala tong square. Tama ba? Dapat S lang to. Kasi kinopya ko lang to dapat dun. So nagkaroon ako ng S squared dito. Derivative ako ng Laplace transform. Nag-Laplace transform ako ng second derivative. Kinuha ko yung Laplace transform ni X. So dapat S pa rin to over S plus. Tama, no? Dapat S over S squared plus 1 lang ito. So wala itong square. Wala rin itong square. Agree? Okay, thank you, Kiefer. And then dapat ito ay S lang din. 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 Gusto ko kasing padaliin yung problem. Tanda ko hindi ito ganito kahirap eh. Kasi magpa-partial fraction decomposition pa ako doon. Pero let me see if I can avoid doing partial fraction decomposition here. I think I can't. So kailangan kong tingnan yung S over S squared plus 1 quantity squared. Dapat ko itong isulat as something over S squared plus 1 plus something over S squared plus 1 quantity squared. Kaya lang magkaka-Laplace transform ba ako sa S squared plus 1 quantity squared? Let me just check my list. Meron ba ganyang formula? Meron tayong S squared plus 1. Hindi lang ako pwedeng mag-exponential shift kasi pag nag-exponential shift ako, ito yung mapapalitan. Yung S ang mapapalitan. So I'll have S minus 1 quantity squared, saka pa ako magpa-plus 1. Tapos saka ako mag-S, factor out ng S, kakaroon ako ng mga S sa ilalim, S, S, S. Ha! Mapapalaban yata ako sa example na to. Dapat hindi na ako nagka-typo. But anyway, so let's see. Ito dapat yung mangyari. Alright. So, mukhang kailangan ko mag-exponential shift kasi kita niyo yung problema ko rito kasi ito ay matitira sa denominator. The problem is, I don't know or we don't have any formula that involves the Laplace transform of a fourth power. And I cannot factor this any further, right? S squared plus 1 quantity squared na lang siya. Hindi ko na siya mapafactor talaga. So essentially, I need to have a formula para sa Laplace transform ng AS plus B. Pero wala tayo sa listahan natin. At least sa listahan natin, wala tayong Laplace transform na may S squared plus 1 to the power 2. Double check ko yung listahan. Wala talaga. Right? Tapos hindi ako basta-basta makakapag-exponential shift kasi meron itong plus 1. So kailangan ko ay exponential shift na hybrid. Pero algebra lang naman yung kailangan ko. So what I'll do is this muna. So I'll multiply. Tingnan ko kung mag-work. Hindi ako sure kung mag-work ito. So ito ay isi-shift ko na, ay kaya lang plus 1. Mag-shift ako plus 1. Ito nga pala ay magiging plus 1. So magkakaroon ako ng plus 2 kung mag-exponential shift man ako. Ay nako, yan yung nagagawa ng typo. Napapalaban tuloy ako ng pagsosolve. Pero let's see, exponential shift. Bala ko kasi mag-exponential shift ng e to the negative t. Para sana maging s minus 1 over s minus 1 squared plus 1 quantity squared. And I was hoping na maka-cancel yung 1 para mas madali yung partial fraction decomposition. Pero yun nga pala, ito ay magiging 1 over s squared minus 2s plus 1 plus 1. So magkakaroon lang ng plus 2 sa denominator. And I'm back to square 1. Come on, think about it. S. Yeah, hindi ko maiisip yung trick. Do you guys have any idea? Kasi lahat ng formula, ang meron lang tayo na may sa ating listahan na mga Laplace transform na may power si S na mas malaki kay 1, na mas malaki kay 2, ay yung t to the n when Laplace transform will give us n factorial over S to the n plus 1. Kaya lang, meron kasi itong panggulo. Hindi ko ma-shift kasi ito kasi meron akong S squared plus 1. Fail yung example ko. Pero anyway, so dahil magta-time na rin naman at ito pa rin yung gagawin natin next meeting, section 4.7, all right? So try to do this. Same problem pero mali kasing right-hand side ko. Ang talagang problem dapat ay sorry about that. Quite embarrassing, but anyway. Yeah. Dapat ito ay cosine ng 40. Okay, para hindi repeated factor yung nasa ilalim. Kung tama yung nakopya ko last time, ang dapat makukuha natin ay x tilde s equals s over s squared plus 4 quantity times s squared plus 1 plus 1 over s squared plus 1. Ito sana yung makukuha natin. Tapos pag ni-Laplace transform yan, pag in-invert Laplace transform yan, So, ganun pa rin. Itong last term na to, alam natin yan ay sine t. Okay. Sorry, x of t to. Si x ay function ni t. Tapos ito, magpa-partial fraction decomposition ako dyan. Pero mas madali yung partial fraction decomposition nito kasi magkakaroon lang ako ng a squared plus b over s squared plus 4. Sorry, not a squared, sorry. Kakaroon lang ako ng as plus b over s squared plus 4 plus cs plus d over s squared plus 1. If I am not mistaken, this is exactly the same problem as example number 6, yung partial fraction decomposition kay number 6. So a is equal to, what did we get? Here, a would be 1/3, and then b, and then c is negative 1/3. B and d are both 0. So madali yung inverse Laplace transform. So you can play with it and try to show that this is going to be 1/3 cosine and t minus 1/3 cosine and 2t. And see that this is our particular solution to the ODE, or to the initial value problem. And I solved it not with variation of parameters, not with undetermined coefficients, not with homogeneous homogeneous solutions and the non-homogeneous solutions combined. Wala akong ginamit na calculus dito. Right? Kinuha ko lang yung Laplace transform, nag-solve lang ako ng algebraic equation, nag-inverse Laplace transform ako. Right? And this is actually the gist of section 4.7. Pero dahil hindi natin na-cover, kunwari, yung section 4.7, pero alam ko dapat kaya nyo nang i-extend yung natutunan nyo from 4.1 to 4.6 papunta dun sa laman ng 4.7. Pero let's pretend muna na wala pa kayong idea kung paano gagamitin lahat sa section yung natutunan natin sa Laplace transform papunta doon sa section 4.7 para hindi na muna kasama sa pre-final exam yung 4.7. Ano? So prepare for the pre-final exam hanggang 4.6 muna. Hanggang sa inverse Laplace transform muna. All right? So with that, do you have any burning questions? All right? So if they're done, so thank you guys for joining me today. Good luck on the exam on Monday. So I hope to see everybody on Monday. Ano? Kahit yung mga mag-special exam because of conflicts in schedule. So, abangan nyo ako ha. Huwag kayong aalis. Pag 10, wala pa ako sa 101, sa MB 101, huwag nyo akong iwan. Pupunta ako ron. Ano? So, give me just some travel time from UP Rural papunta sa math building. But I'll see to it that you'll have exactly 2 hours to finish the exam or to finish the first part of the pre-final exam. Right? So you guys have a happy weekend. And again, kita-kits tayo on Monday. Bye, everyone.